All right, let's say just 49 degrees just for today. Okay, so 49 degrees is this angle in here. It's called the reference angle or the original angle. So that's 49 degrees. That gives 0.75. If we think about sine, we always think about the y-axis. So it's what's coordinate on the y-axis. So that up there is 0.75. We can say that that point is 0.75 y-coordinate. The y-coordinate is always the sine of the angle, and the x-coordinate is always the cosine of the angle. And we can go around and around the circle as the angle gets bigger and bigger and bigger, around more than 360. We only have to go 0 to 360. There are two places where that angle is negative 0.75. We already picked those out here. And they're directly related to this angle. If you're looking for the angle in this quadrant, it is always 180 degrees plus what I would call the reference angle. If you're looking for anything in this quadrant, it is always 360 degrees minus the reference angle. If you're looking in this quadrant, which we're not, but if you ever need to, it's 180 degrees minus the reference angle. Now, what's the reference angle? It's this angle, 49 degrees. So when we go around the circle, there will be 4 times where it's either 0.75 or minus 0.75. 2 of them are positive, 2 of them are negative. What you need to know in the unit circle as well is that because sine has got to do with the y-axis, sine is positive only in these two. So actually everything is positive here, sine and cosine, because all x points and y points are positive. Here only sine values are positive because an x coordinate over here would be negative. Here, sine and cosine are negative, which means actually tan is positive because tan is sine divided by cosine, so a negative divided by a negative. If you ever need to find tan, you divide a negative, or divide sine by cosine. And then this one, cosine is positive. These are all, I'm saying, well, positive. So there's a bunch of stuff. Now I rushed through that because we've done it before, but maybe I might need to do a lesson on this again because it does tend to be an information overload. But that is something we need to think about when we're given this kind of question, which looks for more than one angle where a particular ratio is got. So if it was 720, there would actually be 4 answers to this question. So what are the answers to this question? Well, we wanted it to be negative, so it's these two. Sine is negative in both these quadrants, so we just do 180 plus 49 to give 229. That's one answer. And do 180 minus 49 to give, what is it, 311, is it? 311. And there are my 2 answers for x. X can be 2 things. Now the second question is slightly different now. It's about the look of a sine and cosine curve. That was with me. In body anyway. All right, so sine and cosine curve have the same kind of look. We're looking specifically at a cosine curve. You should know what one of those looks like in general. It starts, if I start at, let's say I want to go 0 to 360 degrees. Where does it start? What's that value here? 1, and it goes between 1 and minus 1. Cosine actually starts at 1 because cosine of 0 degrees, if we go back to our unit circle, cosine of 0 degrees, this is our angle, hasn't moved yet at 0. That is 1 over here on the x-axis because the unit circle 1, the radius is always 1. Okay, so 1, and then cosine moves around this direction, and at 90 degrees, actually the cosine is at 0. This point here, at 90 degrees, there's a 90 degree angle. This point on the x-axis is 0. So at 90 degrees, we know it hits 0. At 180 degrees, it goes back, but it's at minus 1 now. Because the cosine is on the x-axis. What's this point? Well, that's minus 1, 0, so that's down here at minus 1. So this is what a cosine curve looks like. It goes down to minus 1. Then you can see it comes back to 0 before completing at 360, will hit 1 again. Okay, so that's what a cosine curve looks like in general. But that is the function y is just cosine x. Nothing's done to it. In this question, we're looking at y is p times cosine qx. So we had some transformations done to this. So it's a multiplier. And it's said that the amplitude of the one in this question is 3. The amplitude of this original cosine is what? 1. You can think, well, you think of a multiplier here of 1, or you can just look at it, how much it goes between the median point and the highest point is 1. Or you can think from the highest to the lowest divided by 2 is the amplitude. So if the amplitude now is 3, that goes up to 3 here on the x-axis and down to minus 3. But the multiplier here would be 3. It just multiplies the function by 3. It gets 3 times bigger. And the period is 30 degrees. So there's a couple ways you can think of this. This one repeats, that's what a period is, how often it repeats. It repeats every 360. You see we're back here at this top point at 360 degrees. Now it says that it repeats every 30 degrees. So you can think about, right, what used to repeat 360, this one, now repeats every 30. So how many of those fit in there? 12. Yes, so our multiplier is going to be 12. Another way you can think about this, if you ever see a period of a function, is 2 pi over whatever the multiplier is here. So the period of this function is now 30. 2 pi over b, what am I doing? That's a b. 2 pi is 360 degrees. Sorry, I'm used to radians from IB. But I can solve this equation. 2 pi is just 360 degrees. B is this multiplier here. Which is also 12. I'm just giving you the second way of figuring it out. B is 360 divided by 30 if you want to rearrange, and that gives you 12. If you like this formula, which you'll have to use in IB, maybe change it to 360 if you want to write it down. That's the multiplier here, the multiplier of x. Okay, so once you've figured out that it's 12 either way, our function is this, 3 cosine 12x. And it says, right, put 10 into this for x. So if my function is 3 cosine 12x, if I put 10 in, I get 3 cosine 120. And then I need to go back and know my unit circle again. So what's cosine 120 degrees? 120 degrees sits here. What angle am I looking at? Well, I'm looking at this one, not all the way. I look at this one as my reference. What is it? 60. 60 degrees. So what's cosine 60 degrees from our known 1/2, yeah. But because it's in this quadrant, we know cosine is negative. So we're looking at cosine 120, negative 1/2. Okay, and that's how we do it. So the cosine is negative in this second quadrant. Only sine is positive in that quadrant. Okay, that's quite a tricky question. You all right, Lucas?
Yeah.
Ask the question. Or Charlie, ask the question.
Yeah, Charlie.
What's the question?
Oh, no. I was figuring out how Lucas got to negative half so quick, but he's just good at the
He knows his unit circle, yeah.
Yes, I do.
Perhaps we'll do more on this another day. Who wanted me to do the surface area one? You guys.